There we go, now you can hear me. Great, so what we have now is, whatchamacallit. Invalid block. I should FSCK this. I should really FSCK this. I think what I do is, well, here's how I do it. Okay, we have to mount host fs. Okay, file system has errors. So here's what we do now. We force a sync, check again, I guess. File system still has errors. Fix the file system, and now shut off without syncing. And should be good now. Hello, VM and PN. All right, we have a working file system, and hopefully I don't have any weird bugs that break the file system. So, oh yeah, what was I doing? Foo. Git status. Okay, Git works. Actually, that was a little bit slow. Maybe I can look into that later. Git works. How about, oh yeah, I tried git clone earlier, that didn't work. So my guess is threads are, let's write and run a test program that uses threads. Oh, fuck. All right, we need to expand the virtual hard disk, which is, I think, 256 megabytes now. But luckily this is easy. You run this truncate command. Be very careful not to accidentally decrease the size, because then you would totally break it. Then you can go resize 2fs. Resize the virtual file system does not support online resizing. Why is that? Online resizing, not inline resizing. Dumb. There we go. File system does not support inline resizing if not X2FS has feature resize inode. What's this? Actually, what is MetaBG resize? Why am I here? Okay, that is X4 sysfs. Something? It's like some kind of thing. I'll get it. This doesn't explain very much. It's just like an attribute that like you can have. I'll get it. What the fuck is this? Interesting. Okay, so the idea being, wait, why is this using an environment variable? That makes no sense to me. Yeah, I guess, so yes, this is some kind of kernel feature that makes it support live resizing better, but we hit this, or this. Huh. Maybe I should get strace working here. Maybe that would be a better way to see what happened. Is there some online troubleshooting on this? To view full details, sign in with your My Oracle support account. Oh, interesting. Old disk blocks equals 1, new disk blocks equals 4. So we can see that actually we're tripping this. So what's going on here? Oh, do we not have sysfs mounted? Okay, that's easy. So we do have MetaBG resize. Okay, so the file, I guess this is happening because the file system was created as X2 and not X4. Maybe this can be, maybe you can like upgrade the file system. Upgrade X. This is almost certainly not something that can be done while it is mounted. The recommended thing is to back up the volume, reformat, and restore. No thank you. It is also possible to just mount X2 file systems with the X4 module, which is what I'm doing. You're strongly advised to not do this. Okay. I don't know, this kind of makes me want to give up. Anyway, I'm not even going to ship this. Um, okay, but it is apparently possible to enable journaling, but you don't get like all the good shit. Uh, yeah, I guess it's just not possible. All right. What is it again? Backup, reformat, restore. All right, I could just tar this up. Like, how much crap do we have? 250 megabyte. Well, let's delete Docker, build base, then it'll be much smaller. I have in mind to just reformat the entire, just wipe out the whole thing. Okay, now we have. See, the reason I don't necessarily want to wipe out the whole thing is I forgot how to create it. I mean, I guess we can figure that out. But yeah, okay, now all we really have is Git. Oh yeah, someday I should fix the screen size thing. The screen is the wrong size. It's um, I think this is like 80 by 24, like the default. Yeah, and yeah, that's not great. Yeah, you know what? All I have here is this giant pile of shell history. That's like the only valuable information here, and I should just get rid of it. It's not actually doing me much good. So, um, what should we do? I know. Let's do this. Do we have hostfs? No. Mount hostfs. Okay. Here's where the image is. I think we gotta. The command is allocate. Let's make it, whatever, 128 megabytes. Actually, let's make it 1 gigabyte. Gotta have room to grow. Applying 2 to IMG because we are creative. Not supported. Maybe hostfs just doesn't support this. Huh. I kind of want to fix it, and I kind of don't want to like go through another level of recursive yak shaving. What can I do? I'll just look at it for a moment. Hostfs. Kern. Actually, what does fallocate do? Hello, eyes. How goes it? What is this? It's gonna be easy. Just read the source. Yeah, fallocate. Or at least the fallocate command. I'm gonna take a guess that it is just a wraparound. Yep, the fallocate system call. Yep, fallocate. Where's the thingy? Oh, here it is. In fsopen.c. Oh, hey, I just got an email that's relevant to the current project. I noticed that how do I work this thing? I noticed that the Linux Git repository has this has files with has both uppercase and lowercase versions of the same file in some cases, and this sort of breaks the repository on Mac OS. So I think I might have gotten to the guy who wrote UML to respond to this. But yeah, he makes the point that some of these files that have uppercase and lowercase variants are in the UAPI directory, which means they cannot be removed or ever because user space can include them, and you do not break user space. So we're probably stuck with a broken repo. But actually, it's nice that I now have someone to ask about how UML works, because I've been sort of puzzled about it before. Um, but anyway, um, yeah, so fallocate just calls into VFS fallocate, which has like 500 different ways it can fail. Well, the specific one we got was not supported. EOP, not sup. More likely it went into this. Huh, dark theme, you say? All right, let's do it. There you go. Dark theme. You'll notice that nothing changed. But that is because that is because I am in iTerm and that just is already in dark theme. So this makes no mention of fallocate. Oh, here's the op not sub. That's it. So I was right. It just doesn't support this, which means I gotta be peasant and use the truncate command instead, which accomplishes pretty much the same exact thing. Well, almost. I think truncate just sets the size field on disk. It doesn't actually allocate the space on disk, versus if allocate will go and allocate the blocks on disk. So let's truncate. Wait, why does this work? Oh, it's dash s. Okay, now we can. Wait, this didn't do anything. What? Why is it not showing up in the directory listing? Wait a second. So it's there, but it doesn't show up in the directory listing, which means my hostfs is buggy. Oh man, this is going to be a series of nested rabbit holes for a while. Now, hostfs is mostly the same as it is in UML. The one thing I did change is directory listing. Where is it? Dir something or other. Read dir. Oh, I must have changed it in hostfs kern. Dark. Wait, what was I looking for? Fuck it, let me check the Git history. Yeah, that's it. Okay, so the thing I changed here is in hostfs reader. Basically, we open the directory once when you open the file star, I think it is. Um, watch this. Fuck. How about this? Fuck. Wait, okay, so... Oh, okay, right. The dir pointer is stored within the inode. What I did was, the inode dir pointer gets, like, opened once, uh, and then in the future you read from the same exact dir pointer again and again, because, uh, because it turns out, well, reader returns like this offset, which you can use to like continue reading the list of directory entries at the same point. But on macOS, these become invalid after you, after you close the directory, after you close the file. Like on Linux, on X, for example, the offsets are like they're actually a hash of the file name. But like on ext4, the file names in a directory are like they're stored in a hash table, and you iterate through them like by just iterating through the hash values in like the order in effectively random order because it's like an order of the hash values. So your seek offset in the directory is the hash of um, like the next thing you want to read, or the last thing or something. Um, macOS doesn't have anything this elegant. Instead, I think it has some. God knows what it's doing, but when you close the file, you can't use these seek offsets anymore, so ls was just broken. So now ls works, but the directory listing can never update because apparently there's some other flaw in macOS where, probably directly related to this one, where if you close the file and if you don't close the directory pointer, you don't close the dir star thingy, you just get nothing as your like you don't see new changes to the file system, which is interesting. I don't know what to do about this. I want to ship this, which means I should probably get it to work. But I don't know how. I don't know if we could. We could check the timestamp on the directory. If the directory has been modified since we last called readdir, we have to reopen it. That's a possibility. I kind of want to file this away for like later. Like, I'm probably gonna ship without. I'm probably gonna forget to fix this and ship anyway. But whatever. It's not the most important part of the thing. I mean, I should check whether directory timestamps actually do what I want. lsd dot stat dot. This timestamp is when the hell's this? This is 218, and if I like touch okay, now the timestamp updates. So we could do a timestamp thing. That might work. Oh yeah, I got another email from Alviro. Let's see if I can navigate the macOS-Linux system. Yeah. Anyway, moving on. We can we should be able to mkfs ext4 on this alpine2.img. Boom, done. And mount it, I guess. Well, let's mount it on like /media or something. Media floppy, that's a good one. Oh, we should create, I think we need a loop device for this. For which you need LO setup. however that works. Okay, LO setup. I guess you just pointed at the file. Not TTY, okay. Oh, you have to associate it with a specific loop device, the loop 0. There we go. That'd be good enough. Okay. Right now you have to untar the Alpine mini rootfs onto this. Okay, that worked. Are we done? We're probably done. Yeah, let's try boot it. Let's try and boot this. Alpine 2. Yep, that works. And it is X4. And let's just get rid of the old one. I mean, we can take this time to like figure out where. Let me just. initramfs seems to be like basically my scratch directory, even though it has more than just an initramfs in it. Alpine root. I have no idea why this is here. BusyBox is here because it goes in the initramfs. Init.sh also is part of the initramfs. Sure. Yeah, we good. We don't need to really print K anymore. Okay. Oh, fuck. How am I gonna fix that? I think I'll need to get my initramfs. Actually, I don't know what exactly is wrong here. Yeah, let's, This is very opaque. Actually, you know what? Something we could do is, init equals bin sh. Alright, now we can, I think I might have just wiped out security.ty. I remember this being a problem when I was first bringing up ish, security.ty.back. That was not it. Was the password legitimately wrong or something? I don't get it. Alright, you know what? Here's what we're going to do. We're going to get strace working, and then we're going to use strace to diagnose this. And we will be using init equals bin sh in the meantime. Okay, so as a test, login root, login incorrect. strace login root. I expect this to not work at all. Wait, what even did that do? It just stalled for a second. The fuck? Okay, here we can see BusyBox took an IRQ, showing its stack. strace is nowhere to be found. What if I just run strace? Alright, what the fuck? Am I gonna need strace to debug strace? Alright, one thing we can do is turn on. Why do we need our W? Interesting. It is actually read-only for some reason. Okay, RW goes there. Process.log syscalls goes here. There we go. Now we have lots of logging, and that should help. Okay, what the fuck? Called syscall3, whatever that is, a ton of times. No, I don't want units 32. I want syscall 32 TBL. Here, 3 is read, and it kept returning 1023. What the fuck is it reading from? And, like, whenever did it call exit or anything? Oh, okay, so user bin strace, right? Let me go use the poor man's strace, which is known as a printf. We don't have the args yet, or we haven't read them in, right? argv. Does this ever hold argv? Hold argc, end of C, file name, interp. But, you don't actually see the. Whatever, never mind. We can at least print the file name. Print K. Name, I guess? Is this the union? No. Alright, that seems about right. Oops, not wrong make target. Wait, why did I don't know why this had to rebuild everything. Whatever. We're seeing prints, right? Yeah. exec_v bin sh strace. Okay, what the hell is this? Why does it immediately turn around and exec something else? Can we print the argv? I'm pretty sure it copies the argv directly from this user pointer out to like the destination. No, it must have an intermediate. No, it allocates a new does a direct user space to user space copy, and so we don't have it sitting on kernel space or anything. You know what we can do though is LLDB. We can break on do exec_v, I think. Would this be copy strings? Yes, I think this would be copy strings. Okay. Oh wait. Oh, it happens twice. One for environment and one for arguments. strace. First we exec strace, which is unsurprising. Then we exec busybox, which is surprising. So let's peek. Actually, we're doing the environment this time. I don't know. We can use this practice. Okay, this is not a valid pointer, but ish mem bay. There's a variable that is something like called something like that, right? Mem. No. Kernel mem. Is that it? It's ish fizzbase. Okay. Which is, I think, a constant, roughly. Is this valid memory? No. Oh, this is a user space pointer. I see. Okay. I guess soon we're gonna. You know what I should be doing is user to kernel. Current. It's called stir. What? There we go. Now we can see pwd equals slash. Is there anything else useful here? Not much. Okay. We can go deal with the arguments now. Okay, stir. Okay, first one's user bin strace. Wait, what? We're execing. Aren't we execing busybox this time? Where's that? Where does it say that? There it is. And yet, our first argument string is strace. It can be killed while it's doing this loop. That's funny. Wow, okay, so... Wait, okay, stir. We got a new stir. Which doesn't exist. What the fuck? Oh, this is the null part of the string. The last argument is the empty string. So... Why is strace doing this to me? Do I have dump stack? I have dump stack. Let's dump the stack. That was the wrong dump stack. I mean, I wanted to know where we are in user space. Oh, is this it? Exec or die? This seems likely. A little bit. But then why would it do this for dash help? Huh. So it can only really be anything in here. And we have this one execv call. So Wait, why the hell would it do this if I just asked for help? Like, seriously. Strace dash dash help. Why did BusyBox sit here and read a shitload of stuff out of some file descriptor for no apparent reason? Wait. Are you trying to say that it failed to do this, so now it's doing what? BusyBox definitely does not include an strace. What is this shit? What is -8 again? You're no base. -8 is enode. Enode exec. Whoa. Okay. Do a file? No. Let's go and take a closer look at that enode exec. That probably went fine. We would have gotten into, I guess, the file format code, exec binperm. Yeah, I should have broken on exec binperm. What? Is it not an elf or some shit? Oh, and then it would busybox. Let's let's VI this. Oh my god. How did it all end up as null bytes? Right, that was. This is weird. This is very weird. Yeah. Hi, Creepinson. How goes it? Never seen my face. Yeah. Okay, this works. That's not a bunch of null bytes. Good. Now it works. Okay, let's try, oops, no. Let's try it now. Huh. And now it got murdered. So I guess I'm gonna have to get used to this as a behavior of hext, where like if you create this file, I notice every time it recovers from the journal. Yeah, I guess I would have to trigger a sync for it to actually work. So let's fix strace. That should do it. Yeah, okay, and then we can sync. Now, if we restart, it should be good. Okay, I mean, let's test this with like some other file. Oh, it didn't even make it there. All right. Yeah, you gotta sync the file system or shit goes away. I gotta remember that. Anyway, where am I? Root. Can we strace anything? Nope. Can we strace like this? Nope. Yeah, we're in a fucked up state. Actually, let me dump more of that state. Okay, shell's waiting. Where are all the kernel threads? strace is wait for. ls is at ptrace stop or something. Okay. So that's nice. All the semantics of ptrace, stop, signal stop, root stop, all that bullshit gets automatically done for us, but not like anything else. Here I wish I could strace, but it was not meant to be. In order to strace, I would need to have strace, and I do not have strace, so I cannot strace. I mean, if we can get this working, this is already going to be an improvement over iSH as it is these days. Because iSH today just doesn't support strace. Exec VE ptrace. Wait, okay, so we're stuck inside of exec VE on a ptrace stop there. Meanwhile, strace goes, okay, stray ptrace event exec. Why is that considered a stray? Event? Does it say? No, it just says stray ptrace event exec. There we go. What is TE? Trace event. Huh? Okay, so we have some kind of... Oh, I see. The problem is we're not sending system call. We're not telling the kernel when we get a system call. So it can't send this information to strace. So strace sees this ptrace event exec come out of nowhere. So let's fix that. Plan of actions to, I guess, look at what other architectures do. Like, okay, how about arch kernel? I don't know where I would look though. Process? Is this it? This could totally be it. Okay, so user space. I think we find this in arch scas syscall. Okay, this has to be it. Right, so you have to call syscall trace enter, is my guess. But I don't know where that is. Syscall trace syscalls. This is a function, right? Yeah. Wait. Huh. Yeah, I'm looking at the wrong file if I want to find a function. Oh, this must be in UM. Okay. Arch UM. Ah, kernel ptrace. Here we go. So we go audit syscall entry, and then trace hook. I assume this is eventually, yeah, this is going to go to ptrace. Okay. Out of curiosity, what do other architectures do for trace hook report syscall entry? They all call it at some point or other. Most of them from a file called ptrace.c. x86 calls it from entry common, but seems to be the odd man out. What's up with, I'll pick one, like RISC-V. Okay, so it has this one function that handles all of the weird hooks you have to call on both entry and exit. I think we should have one of those too. And we too can call it ptrace.c, but what other crap happens in ptrace.c? Okay, you can declare your arch-specific ptrace requests if you want. I don't know how many of those we'll have. Wait, actually, you need a lot of them. I'm dumb. Wait a second. This is effectively a no-op. This doesn't need to be here. What probably does need to be here is task user reg set view. I need to make one of these for x86, read the registers out, or else register reads won't work. And that is probably also going to block features from working. But at least it won't get this exec v out of nowhere, or event exec out of nowhere. Yeah, we need a ptrace.c. Oh wait, I already have one. Good shit. Okay, I have these two things that do nothing of value. What is ptrace disable supposed to do? And I will need an exit version of these, and I have no idea if they're supposed to return it. Probably int, because trace hook thingy returns int. Implicit declaration, where are they? Tracehook.h, okay. Does that do it? Yeah, okay. Too few arguments. Expected to have one. What? Oh, exit requires more arguments. Interesting. Right? Exit and step. What's step? 0. Oh, who knows? Wait, this needs a different name. I kind of want to compare to what does. Here, yeah. Okay, I like this. Okay, the three things you have to do is audit, trace hook. Wait, oh, what does this thing do? Trace hook, set comp, syscall trace points. What are those? And then audit. Okay, pgregs. pgregs has everything. Has all the registers we might need for syscall arguments. But they could differ per arch, so we should probably have defines. Be like, syscall number is going to be AX, or is it going to be a ridge AX? Probably a ridge AX. I don't remember. I mean, the reference for that would be iSH process.c. Yeah, a ridge AX seems right. Syscall. This is like guarding against one day when we'll support multiple architectures. Actually, should I bother? I won't bother. Yeah. Okay, so we should only do this if test trace flag syscall trace from asmthreadinfo.h. Who knows where that comes from? Oh, from Linux thread info, okay. Null void function does not return. Wait, why isn't this working? Linux thread info. Is it the wrong number of arguments? Oh, test thread flag. Here we go. Now we can return 0. But we have to call. Well, okay, just does audit and trace hook. We should probably do setcomp. We should probably do setcomp. Right? I mean, there's the option of just, who cares about setcomp? We don't support setcomp. Wait, what are syscall trace points? It's a, I accidentally opened text edit somehow. ftrace, okay. Oh, hey, Vapier. what was system? I forgot what it's called. Syscall. Yes, syscall trace points. There it is. I don't think we'll support ftrace at all. Actually, you never know. Uh, how does it work? I know it's just for function trace, and I think it manages to trace every. Actually, this will probably be good. It lets you trace Linux function calls. Okay, so this will like tell you whenever it like calls a particular kernel function. Interesting. So it seems to have hooks in every like at the start of every kernel function, and I don't know how it works. Oh, it hot patches the code. Okay, that will never work in ish. Um, I mean, maybe there's I saw a reference to mcount, I think. Uh, oh, wait a second. Um, huh. Okay, wait. So the mcount. Okay, with the PG switch in GCC, is this supported by Clang? Is Clang command line flags? Um, Google might have gotten it in for Android. PG, yes, it is. PG will add a call to mcount at the start of every function, so that's cool. Then there's mf entry, whatever that is. Um, I guess that's a Clang thing too. Then mcount lock. Interesting though that this isn't the default. That ftrace um, can work without this, maybe? How does non-dynamic ftrace work? Hmm. Okay, you need to implement the mcount function. Is there a section on dynamic? Yes, so you have to do different things for that. You will first need have function tracing. You need to do all this crap. What if you don't? Does it still work? You need to write the mcount function. Um, let me try this command to see if it works on Mac. It does, okay. So you do have an mcount symbol on Mac. Uh, So, okay, this might work ish eventually, but I have to do all this work to make it work. Which is not limited to just adding that little if-def thingy that I saw on the RISC-V, so let's not bother for now. This might just be it. Should we have audit? Do we have to? Okay, audit syscall is a config option. But can we say we don't support it? Might not be. Yeah, I don't think we can say no to this. Yeah, let's just throw in this audit syscall entry call. Why not? Audit syscall entry. Okay, this requires all 4 arguments. Remember, you can never have more than 4 arguments to any system call except mmap. What are the arguments again? Number, and then 4. Okay, I'll be rex or regex. If I remember the convention right, it's just bx, cx, dx, di. I think probably. Oh, it's over here. CX, DX, SI, DI. Okay, that should be SI. We're good, right? We have to include Linux audit. Now we're good. And we've got to round out. Wait, does this return anything? No. We've got to round out trace syscall exit. Audit syscall exit just takes the regs. How do you do this time? If it's very simple, if test trace thread for lag, thread for lag, Okay, this is void. This will be called if syscall trace is set as attempted a system call. Safe to block here, preventing signals from being processed. If step is non-zero, this is also in lieu of the normal track that would follow the system call instruction. Interesting. So it sounds like it's arch dependent whether this is ever used at all. Yeah, seems like some arches just always set it to 0. UML always sets it to 0. x86, being an oddball, has a variable. Maybe I'll need a variable. Well, okay. also does x86. I don't fucking know, man. It's probably fine. Yeah, let's try it. But of course, first we have to rebuild the world. Oh, ooh, okay. Expected semicolon. A little bit of stupidity there. Oh, this is because we changed, wait, what the hell is going on here? That doesn't need to be there. This is because we changed PT regs, right? Does that even need, why does this need to return an int? Also, we forgot to hook this in. We forgot to call it. God damn it. This apparently can just return a void. We need to call it from over here. How does RISC-V happen to do this? Do they have a particular place they like to declare these sorts of things? No, it's just called from assembler. Well, that makes that easy for them. Probably has a header file somewhere. Is it ptrace ABI? No, it is not. This is used for a slightly different purpose. Oh, interesting. There's other stuff here, too. Why are we faking a debug trap? What's PTD trace? Oh, man, this is such a pile. Oh, hey, this seems relevant. RQM seems to be the only user of PTD trace. Alright, let's not worry about it. Well, this patch didn't land for no apparent reason. Whatever. Okay, next we just... Oh, wait, I had a question I wanted to answer specifically. This is called trace leave, RQM. They have a ptrace generic header. Sure, whatever. Actually, that's not a bad place to put it. Sure. Wait. Oh, okay. Yeah, I'm gonna put setcomp inside the thingy. Wait, where does it send a SIG-sys? What? What the fuck? I don't know. Yeah, let's go ahead and call trace syscall enter. Actually, why would this return a failure code? If a fatal signal is pending. Gotcha. What's do signal? Oh, this is handle any signals. Alright, maybe we, yeah, maybe we have that do the same go to. if go to signal. Okay, that will probably improve the situation. Nope. Void function should not return a value. At least that's easy to fix. Sus. It's very sus. Okay, what happened? This is good. This. I assume this is the child. It's sitting waiting in what I assume is the entry to execv, and um, yeah, this is the parent, and it's just waiting. So, I don't know, and also I have no idea what these 4 question marks and open parentheses are supposed to mean. Oh. Oh, that must mean it's like the question marks represent I have no idea what the system call is called, and the open parentheses is the system call is beginning, and then if it's sitting and waiting, then it's like unable to print the arguments. So it's stalled trying to print the arguments with this call. So that does make sense as output of strace, I think. Well, I mean, I can search for 4 question marks here. Yep, that's it. Right, this is if it can't find anything else. Is there like a verbose like debugging output spew mode? That would be useful. That's always useful to have. Wait, why is the output cut off here? That is funky. And why exactly there? Actually, it's not always exactly there. It's different each time. That's such a rabbit hole of bugs. All right, let's ignore that bug for now. We'll fix it later. Oh man. Show some debugging output of strace itself on standard error. This is useful. Set options, get syscall. Get syscall input does not work. What is this, and is it in fact supposed to always work? Since 5.3, I guess it's not under any obligation to work, right? But I don't think it is arch dependent. Shouldn't be. ptrace get syscall info. Oh, here we call syscall get ner. Ooh. And then syscall get arguments, which, how does this even build? I don't remember writing one of those. Huh. Does everyone? Yeah, it looks like every arch writes their own, but then did I and forget about it? No. Syscall get arguments. This isn't behind an ifdef or anything. What? Alright, I think we're going to need a little bit of a breakpoint on ptrace get syscall. Yeah, how about just this? ptrace get syscall info. See if we hit that at all. We do not. Okay, seems right. Okay, it's entirely to find out. Someday I will do this, but I guess it's not actually needed for strace. So. Okay, ptrace get syscall info does not work. Good to know. TCP for pin 22. What's a TCP? Thread control block? Maybe? Trace control block, okay. I assume there's one per process or per task. Okay, we call wait. Wait returns 22, the child, with stopped, sig stop, event stop. Sig trap event stop. Next event queued dequeued. This seems to, well, this didn't produce any log output. Okay, all we have is the series of events without, like, log output. Now, you know what I should do is boot up a real Linux VM and compare with what that does. Phew, that was a lot of spam. Okay, let's look at startup. Get syscall works. Okay, it's doing a test. Sig stop event stop. GZB startup. Sig trap event stop. Sig cont. 133. Then nothing. I should have traced true. There's less crap going on. A little bit less crap. With glibc, there's always too much crap going on. But yeah, it just drops off for no immediately apparent reason. Oh yeah, I dumped the stack. I tried dumping the stack before. Oh yeah, we really need to fix that where it fails if there's too much crap to dump out. I tried to dump the stack before and it went, we're waiting. You are sitting on a syscall. I never found out what syscall. At least not for sure. Oh snap. Yeah, we might have a little trouble here because GDB doesn't really let you, or LDB doesn't. I don't know. It might be difficult to like long jump onto the stack and inspect it. I think I would have to. I should figure out how to create like fake threads that are able to like long jump here, but like suspend themselves. Maybe set the stack pointer and then set the instruction pointer to something that just suspends. And yeah, but okay, the IP is important sometimes. Oh, just kidding. The IP has been saved here. It's okay. Uh, we can like put it on. We can like find a way to see on stack. Okay, we to-do list, a way to create fake threads so their stacks can be inspected by traditional debug tools. Uh, yeah, I don't know what to do here. Um, I mean, I could just add a print, but I mean, I could find how hard it is to create a fake thread. Why not? Okay, the thread has to be suspended, I think, right? Has to not be task running, I think. Is there a state for um, whatever? Okay, so um, what do we do? I think we just need a jump buff. Um, okay, we have JBIP. JBIP equals that. Oof, it has a stack. So we should try not to call any functions. Ugh. Alright, let's... Is that it? Oh, we have to start the thread. I forgot. Oh, god damn it, this is a kernel space header. We just can't do this in a kernel space header, in a kernel space file. Okay. User space. What useful stuff? This is not very useful. Whatever. Just fucking create a thread, please. Good thing I have Git so I can delete all this shit code eventually. Array initializer must be. Oh my god, okay. So do you have to be like start buff equals. Or but that? Array type cannot be assigned. Oh god, okay, memcopy. There we go. We will now have shitty fake threads. Okay, luckily this is all dead code until I call it in the debugger. But now, I think it's task lookup, for fuck's sake. By vpid? Oh, find task by vpid. This would be task number 22. There we go, now we have the fake thread. We have a backtrace! Why the fuck does this even work? Who knows? But it does. Not complaining. Okay, okay, now we can go down into, like, I'm amazed that worked, honestly. But, okay, now we can go up the stack and actually find out what the syscall is. Okay, syscall 146? Right V. Interesting. Interesting. What the fuck? Why that specific one? 130. What does 133 mean? This might be something I would want to throw in Fernosco or something. I don't know. Yeah, I know almost nothing about how this whole thing operates or like what the hell it is supposed to do. Hi, JJO Cram. Right now I'm well, for ish proper, I would read the documentation and then just sort of write something that does the job and also fits with also works on iOS. And I didn't find myself looking at the Linux kernel code much. Today I am porting the entire Linux kernel to run in the app. Um, so it's going to be just direct. It's going to be just using all the code from Linux. If I can get it all to work right. See if this illuminates anything. Okay. Well, okay. Maybe we can look a little closer at this read call. Wait, no, this is a write call. Write V on standard error for some reason. Not standard out. With, I guess this is a buffer. And we have some kind of, yeah, that's not part of the system call. Right? Oh, buffer size. Yeah, okay. Let me turn the syscall logging back on. That should help something. On the other hand, Pronosco is so cool, and I kind of want an excuse to use it again. Whatever. It is, however, not free. So let's give this a try. I think it's processed. Yeah. Okay. Mistrace. Whoop. Okay, we can study this now. So process 22 is the interesting one, right? Do we see any logs from process 20? Oh, because the logs only come after the syscall has finished. And I'd be willing to bet it hasn't managed to finish. Maybe it has finished. Wait, what's process 21? Is that like a test process? Oh, here's process 22. Okay. Let me try and match up these numbers. 224 is getted. 175 sig proc mask. 2 is right to right? No. Oh, that's fork. Huh. Oh, I'm reading the wrong thing. I want to read these. 201 is get UID. 20 is get PID. 37 is kill. Why kill? I don't know. And that's it. It looks like, yeah. Kill. Why kill? I don't fucking know. Wait a quick second. What is happening here? Fork returns 22. But we do this from what? Isn't it only supposed to return this sort of thing in the parent? Like in the child it returns 0, and this is the child, but in the parent it returns the PID 22. I don't know why it's behaving differently this time. Yeah, I can assume that there's just some sort of bug in the logging. That's not some, at least I hope it's not some deep problem. Maybe I've stared at code too long for the day. The hell? Well, okay, one thing I can do is add a print for entering the system call as well as leaving it, which would be here, this file, which is also open here. Why can't I scroll? What is broken? There we go. Yeah, we can just copy this call to be up here and be like syscall foo, it returns bar, painting. And then we don't print the AX because it's going to be the same as a rig AX at this point. I know we've doubled our logging, but you know, it's cool. Yeah, I want to take out this logging as soon as strace is working reliably. Okay, strace ls. Ugh, we ran into that bug where if you spew too much output, it does this. Crap. Oh, that's fun. We're also in a state where we can't hit Control C. That is probably the thing more deserving of a fix. Okay, you know what I want to do is, how much output is it that it can't take? Just like that. It's from like here on down. Oh, we did manage to get everything this time. But this is, how many bytes is this? Approx. 66.99. Very nice. That doesn't look like a power of 2 or anything fun like that. Why aren't we seeing like the... Oh, because I forgot to pass the option to print debug output. strace -d bin ls. Go. Okay. Okay, so now 22 goes into this call 37. Oh, that returns 0. What is 37? Kill. It's weird that we never saw it go into execv. Like, it's in trace syscall enter. So by now we should have printed, yo, execv is pending, and like not have printed anything else. Am I missing something? No. And this is puzzling. I remember I did a bit of debugging and it looked like it was sitting on a write to standard error. Of size 2. Huh. That resembles nothing. Never mind. I thought I saw it like here. I'm gonna take a break. I've stared at code enough.